My name is Doug Laws and I'm the manager of the Magnetic Resonance Facility here at the Research School of Chemistry, ANU. So here we do spectroscopy involving the magnetic properties of the nucleus and the electron. This room is the control room where we operate each of our instruments, which are in the NMR suite in front of you. We have 4 NMR instruments in this facility, ranging from 9.4 Tesla in magnet strength up to 18.8 Tesla. Let's go and have a closer look at our instruments, so come with me. So our instruments consist of the magnet and a console containing electronics. So you can think of the NMR spectrometer as a glorified radio transceiver, where we transmit radio waves into the sample and then we listen to all the frequencies that come back out of the sample. And those frequencies tell us a lot of chemical and structural information about the sample. So in this facility, our superconducting magnets require quite a lot of helium liquid, and unfortunately helium is a finite resource, so we recover the helium boil off from our magnets and re-liquefy it for reuse. These magnets actually are a superconducting solenoid that has to be kept at liquid helium temperature. Around that we also have a jacket of liquid nitrogen to prevent the rapid boil off of that liquid helium. You might be wondering what that squeaking noise is. These come from helium refrigerators that cool our electronics in 2 of these instruments to near liquid helium temperature. And what that does is improves our signal to noise ratio by actually reducing the electrical noise that's inherent in the electronics of our instrument. Let's go have a look at the EPR side of our facility. Here at the EPR facility we observe unpaired electrons, and like certain nuclei, the electron has a magnetic property called spin that allows this kind of spectroscopy to occur. I guess the #1 use of NMR spectroscopy here at the RSC is for structure elucidation. So research groups will generally be synthesizing various organic, inorganic, organometallic compounds for specific research projects. And when they want to know, have they made what they intend to make, NMR spectroscopy is one of the go-to tools to confirm that you have made what you're hoping to make. Thank you for visiting the MRF facility and learning about the tools we have here to conduct chemical and biochemical research.